We're going to talk about geometric sequences and geometric series. So I already have on the board an example of a geometric sequence where you can see that each time we're constantly multiplying by the same number to get to the next one. And that number, we call that an R or a ratio. That's what the R stands for. Or sometimes we call it a common ratio. And it makes sense to call it ratio because if you were to take any two terms and divide them, like let's say you did 8 and 16, well, you would get that thing that you were multiplying each thing by. So you're multiplying each thing by 2, so 16 over 8, that gets you 2. Any two terms, you divide them, that's called a ratio. So anyway, the thing that you're multiplying each number by, common ratio. Now, a geometric series is when you don't just have a list of those numbers, but where you're adding those numbers up. So instead of just putting 1, 2, 4, it would be putting 1 plus 2 plus 4, blah, blah, blah. So that would be an example of a geometric series. So here's another example. Let's say you started at 3 and you constantly multiplied by 10. Then you would have 30, and then 300, and then 3,000, blah, blah, blah. Okay, so let's say you wanted to have a formula for how to get the nth term of a geometric sequence. Well, it turns out there's a formula for that. You take the first term and you multiply by the common ratio n minus 1 times. And we could say that this one is A1, this one is A2, this one is A3, this one is A4. Let's say you're trying to get to the second term. Well, if you're trying to get to the second term, then you could start with doing the first term times r to the 2 minus 1. So what I just did right there is I replaced the n with a 2. And if you do so, well, r to the 2 minus 1 is the same thing as saying r to the 1. And in our case, for this one, a1 is 3. And our r is the thing that you're constantly multiplying by. So in this case, that would actually be 10. So that means I should replace this r with a 10. So it's really times 10 to the 1. And that makes sense that if you want to get to that 30, which we can see is the second term, then you're supposed to do 3 times 10. And that's another way of saying you're multiplying by 110. Now, let's say you wanted to get to the third term. Well, then what would you do? You would take the first term and you'd multiply by that 10 how many times? Well, not 3 times, only 3 minus 1 times. In other words, you'd be multiplying by 10 2 times. So that's why there's always a n minus 1 here. You definitely wouldn't need to multiply by 3 tens. You would only need to multiply by 2 if you're trying to get to the third one. So if we take that first term, which is 3, multiplied by 10 squared, the same thing as times 100, and that does get you 300, which is what we're supposed to get. Okay, so that is a formula to get you to the nth term if you have the first term and you have the common ratio. And there's also a formula for the sum of the first n terms. So if we get back to a geometric series where we've got 1, 2, 3, 4, 5 terms, I can actually find the sum of those first 5 terms. Now the formula in general is that it is a1 times 1 minus r to the n over 1 minus r. So if we're trying to do it for this particular series, then that would mean we start with our first term, which in this case is just 1, times 1 minus r. In this case, the r is 2. And then it's got to be raised to whatever n is. So in this case, I'm letting n be 5. And then I got to put it over 1 minus 2. And let's see what that comes out to. It's going to be 1 minus 2 to the 5th is 32 over 1 minus 2, which is negative 1. So you get negative 31 over negative 1, which is 31. Now, obviously, you could have just added these up, but this formula becomes much more useful in case I asked you to do the first 500 terms. Then you would definitely want to go for the formula and not add up 500 things on a calculator. Now, if you thought this video was good, don't forget that there's a possibility to subscribe to the channel to try to encourage even more good content. All right, take care, everyone. Bye-bye.